Okay, welcome to part one of my three-part video series on how to graph trig functions that are transformed. And when we say transformed, we're talking about, taking the original function and just kind of changing it, whether we slide it around a little bit or we sort of distort how it looks or reflect it. Right, these are all transformations. So in each one of these videos we'll do 3 trig functions for a total of 9. And I'm going to try to vary them up. Right? I'm not just going to do sine, cosine, tangent. I'll also do secant, cosecant, and cotangent. So we'll try to do some amplitude changes, some vertical translation, some phase shifts, some period changes, and some reflections as well. So let's get started. Let's talk first about the sort of the general form. Right? The general form of these is that we have our trig function right here. And let's say that that's sine. We have this a value, right? The a value will give you your amplitude. The amplitude is basically like kind of like the height of your graph. It's actually like half of the height, but generally speaking, it's how tall the graph is. We'll get more into that in a little bit. It's not really a formal definition, but the b term, that term will determine your period. That will determine your period change. The C term, well, that's going to determine your phase shift. And finally, the D term. The D term is going to be your vertical translation. A translation is just a slide. Okay, so when we get to these things, we're going to basically learn how to use all of these, but there are some formulas here. If this b term is something other than 1, all you're going to do to determine the period of your function is take 2 pi over that b. All right, and we're using 2 pi because that's the actual period of the sine function to begin with. When we get to tangent, then we're just going to use pi over b. Now the phase shift is going to turn basically opposite of this. When we phase shift something, let me explain what it means first. When we phase shift a graph, that means we kind of move it left and right. We move it left and right. And to determine whether you move left or right, you have to look at this sign. And it's kind of opposite of what you think. Right? If it's negative, that means that you probably want to think that it turns left or it moves left, but it actually goes right. So negative means we go right c divided by b units. So you'll take this c and you'll divide it by this. All right. A lot of times you'll see that if the c is different, then the b is just 1, or vice versa. But sometimes if they are both changing, if they're both something other than kind of what they start as in the parent function, then we have to do c over b. And if it's a positive right there, if it's a positive, then that's where we move left, c over b. In the vertical translation, if it's positive, it goes up, which is nice. Right, if it's positive, it goes up. And if it's negative, it goes down. All right, so the phase shift is a horizontal translation. This is a horizontal translation. Translation just means a slide. And the vertical translation is given by this letter, this number at the end. It can also be written at the beginning. It could be out, out in front here, d plus that. We'll also see sometimes if our a value is negative. If our a value is negative, then the graph is reflected. All right, we're going to reflect that thing. But we'll get more into that in a little bit. So those are the basics. I'm not going to go through that every time, every one of these 3 videos. Probably just leave it at that, and then we'll just kind of use that pattern. We'll use this whole pattern every time, replacing sine with cosine or tangent or whatever it is. All right, so let's get into this first one. All right, I see that my amplitude, my a value is 1/2, so that's going to change my amplitude over here. All right, and what that means is my graph, if my graph normally goes up to 1 and down to -1, and it looks kind of like this. That's terrible. My graph normally looks like this. My sine graph looks kind of like this normally. The amplitude of the original sine curve, which is just sine of x, the amplitude of that is 1. Well, the amplitude of our new one is going to be half that. And your amplitude is basically your height, right? So now we're only going up to positive 1/2, and we're going down over here to negative 1/2. All right, so that is the amplitude change. So let me get rid of the parent graph, and we'll just look at the new one. The period hasn't changed. The domain is everything, right? This would, of course, if I wanted to keep repeating this over and over again, it would just keep repeating in both directions. So the period doesn't change, or rather the domain doesn't change. It's all real numbers. The range changes big time. It goes now from negative 1/2 to positive 1/2. The range is the kind of the up and down distance, right? We're only dealing with y values from negative 1/2 to positive 1/2. The range are the y values, a set of all y values. X-intercepts don't change, right? We have 0, pi, and 2 pi. This would be pi. This would be pi over 2. This would be 2 pi, and this would be 3 pi over 2. Our maximum point changes. Now it's pi over 2 comma 1/2. Our minimum value is 3 pi over 2, negative 1/2. No asymptotes. We haven't phase shifted any. We haven't vertical shifted any. And we haven't reflected any. The only thing that's changed in this one is our A value. Alright, so generally speaking, when your A value is less than what it normally is, it's normally a 1. When the A value is a fraction, the graph kind of gets squished. It goes from what it normally is, like up here, and it just kind of gets squished down in half. If that A value were positive, maybe let's say it were 2, then our graph's going to be really tall. Okay? Let's move on. Okay, number 2. Here we don't have an amplitude change at all. There's still a 1 in front. Our period doesn't change. Our B value is 1. We don't have a C value. It's essentially 0. But our D value is negative 1. Our D value is negative 1. So that's a vertical translation, a vertical shift. So that's going to be down 1 unit. All right, so the cosine normally graphs like, it goes up to 1. It goes down to negative 1. And it looks generally like this. Something like this. That's the regular cosine, but this one's just going to be shifted down 1 unit. So it's going to start at 0, 0, and it's going to go all the way down to here. Something like that. I guess I should have given myself a little bit more room on the graph, but that's okay. I think you get the idea. All right, this is a vertical translation or a shift down 1 unit. Period hasn't changed. It's still 2 pi. Amplitude hasn't changed. The domain hasn't changed. The domain is all real numbers. The range has changed for sure. This graph would keep bouncing back and forth. It would keep bouncing back and forth. So we're way down here at negative 2, and we're way up here at 0. So between negative 2 and 0 inclusive, it's your range. X-intercepts, same thing. Well, not same thing. 0, 0, and 2 pi, comma 0. The maximum value, same thing. Minimum value will be right here. Let's see, that's pi units, and then down to negative 2. Pi, -2. No asymptotes, no phase shift, no reflection. So there you go. It's basically just the regular cosine just moved down. Number 3. Here we have a tangent and we have a reflection. So that's a reflection. And we also have a C value. Our C value is going to phase shift. It's going to phase shift left pi over 4 units. Remember we said if this is positive, it goes left. Okay, so let's see. We have a reflection. So what that means is if the normal tangent starts like this, the reflected version is going to be like this. It's going to look more like a cotangent. So we'll take that and then we'll also slide that left to -pi over 4. So we'll take that thing and we'll just kind of slide it left to -pi over 4. And it'll look something like that. Now I'm going to draw it a little bit nicer. My period hasn't changed. It's still pi. Amplitude, there isn't any. The domain we'll get to in a second. The range is everything. The x-intercepts, well, this thing's going to, if it normally crosses at 0, 0, which we've studied, this one's going to cross at -pi over 4, 0. There are no maximums or minimums. And the asymptotes we'll come back to when we do domain. The phase shift we just said was left pi over 4. There is no vertical shift, and yes, it's reflected because of that -a value. Okay, so if the period is pi, that means that, and we know that this is sort of our vertical axis of symmetry, if you will. We've shifted left pi over 4. So we need to figure out pi units from sort of the left to the right of our graph. In other words, our graph needs to encompass pi units in the x direction. So that means from here we're going to have to go left and right pi over 2, because pi over 2 left and pi over 2 right, all together that would be a period of pi. So what I'm doing in my head now is I'm saying to myself, okay, if I start at -pi over 4, maybe I'll actually write it down, and I want to go left pi over 2, where does that leave me? Well, let's get some common denominators. -pi over 4 minus 2 pi over 4, that's -3 pi over 4. So let's go, this would be -pi over 2, and this would be -3 pi over 4. That's going to be my left-hand asymptote. I need to do the same this way, 4 units and 4 units. And my scaling is very, very appropriate. Right? 1, 2, 3, 4 boxes for pi over 2, or for pi over 4 units. So that means I'm going to be right here at pi over 4. Right? -pi over 4 plus pi over 2, -pi over 4 plus pi over 2, common denominators, I get pi over 4. That's going to be my right-hand asymptote. And there we go. So the asymptotes give me an idea of where the graph where the barriers are. So that's x is equal to -3 pi over 4, and x is equal to pi over 4. So my graph is going to, I'll draw it in red, my graph is going to be centered here because we moved left pi over 4, and I know that it normally started at 0. So if I move left pi over 4, there it is. There's my new x-intercept. And it's going to be reflected, so it's going to look something along these lines. Something like that. And if I kind of stop and think about this, I could be a little bit more precise. I always ask my students to be meticulous when they graph these things. So I'm thinking, like for tangent and cotangent, that I have 3 really important points. First of all, I have my 2 asymptotes, but then I have 3 really important points. I have the center point, and then I have in this case, negative pi over 2 and 0. So I want to think about like where those y values would be. So I'll take this over here. I'm going to calculate f of 0 really quickly. So this is negative tangent of 0 plus pi over 4. So negative tangent of pi over 4. I know that tangent of pi over 4 is 1, so this is negative 1. So I'm going to make sure that at 0 I'm going down to negative 1 right there. So now my graph is a little bit different than it was. Something like this. And that leads me to believe that at negative pi over 2 it should go up to positive 1. So let's go ahead and check that one too. So I'm just going to evaluate my function for negative pi over 2. Alright, so negative pi over 2 plus pi over 4, well that's negative pi over 4. So it's negative, and then the tangent of negative pi over 4 is negative 1. So it's negative, negative 1, yeah, it's positive 1. So when x is negative pi over 2, y is positive 1. So I want to just fix that a little bit, make sure that I'm going through the right y value. And there we go. So I've got this key point here, negative pi over 2, comma 1. I've got my x-intercept here, negative pi over 4, comma 0. And I've got this key point here, 0, negative 1. All right, and that, along with the asymptotes, sort of shapes my graph really nicely. So I hope that helped you out. I also have an animation that I might throw in at the end of this video. Maybe I'll even put it at the beginning, I'm not sure, but an animation that kind of shows you, I made it with a GeoGebra program. It kind of shows you what happens when you transform A, B, C, and D. So look forward to that. But anyway, this was part 1. So thanks for watching, and I will record part 2 and 3 later today. Thanks.